One of the most important functionalities that mobile apps perform is storage of data. Hey friends, welcome back to the studio. In this episode, we'll focus on how to enhance mobile app security in the storage of our data. If you're new here, my name is Joy. I'm a software engineer working over a decade of coding expertise specializing in mobile app development. So, what is data? Data refers to the information that an app needs to process, display, or interact with. Think of it as the content that the app uses to provide functionality and deliver a meaningful experience to the user. While data storage is keeping this information either locally or on a server depending on the use case of the project. You could have different types of data. There's when the user interacts with an app, they provide input such as filling out forms, selecting options, or entering text. This input data is essential for the app to understand user intentions and respond accordingly. This type of data is called user input data. Apps often have a state, which is the current condition or configuration of the app. This state is determined by various factors, including user interactions, system events, or external data. Saving and managing this state is crucial for a seamless user experience. This type of data is called app state data. Some data needs to be stored even when the app is closed or the device is turned off. This is what is called persistent data, and it includes things like user preferences, settings, or any information that should be retained across app sessions. Mobile apps often need to interact with remote servers to fetch or send data, and this is what we call remote data. This could be retrieving updates from a social media feed, fetching the latest news, or sending data to store on a server. Handling this remote data is a critical aspect of mobile app development. Images, videos, and other media elements are also forms of data that apps may need to handle. Mobile apps often deal with displaying, uploading, or downloading media content to enhance the user experience. And lastly, we may have apps that frequently use databases to store and retrieve data efficiently. This is what we call database interaction. This could include local database on the device or databases hosted on the servers. Database interactions are vital for managing large amounts of structured data. Great. Data accessibility typically occurs in three primary states. At rest refers to data residing in a file or a storage system. In use, which pertains to data that an application has actively loaded into its memory space. And lastly is in transit, that describes data that has been transmitted between a mobile app and an endpoint or between processes on the device. This is part of the mobile app security series. If it's your first time here, please head over to the beginning of the series to grasp everything we have talked about until now. I'll leave the link in the description box below or at the card above. In this and upcoming lessons on the data storage module, we will look into ways in which our apps can store data securely and practically. So, in one of my many experiences of making apps, my team and I implemented a robust encryption method to safeguard user data in our client's app. However, one fateful day, we decided to enhance security by upgrading the encryption algorithm. Little did we know that this seemingly prudent move would plunge our users into login issues. Users were unable to access their accounts, and frustration echoed through support tickets and app reviews. The problem stemmed from the fact that the updated encryption method was incompatible with the existing hashed passwords stored in our database. Users attempting to log in found themselves locked out, facing an overwhelming cryptographic barrier. In response to this unexpected crisis, we swiftly gathered to devise a solution that would rescue our users from this digital predicament. We realized that a seamless transition required a migration strategy. To mitigate the chaos, we implemented a gradual approach. So, first, we identified users who hadn't logged in since the encryption upgrade and prompted them to reset their passwords immediately. For those actively using the app, we retained dual compatibility. That means allowing the decryption of both old and new encryption formats during the logging process. This dual compatibility acted as a bridge, ensuring users could still access their accounts while the transition unfolded. Over time, as users naturally logged in or reset their passwords, we progressively phased out support for the older encryption method. It was a delicate dance between security and user experience. So, in essence, this experience taught us the importance of anticipating the ripple effects of security enhancements. While our intention was to fortify user data, we learned that a comprehensive migration plan is as crucial as the security measures themselves. It's like upgrading the locks on your house. It's necessary, but you also need to ensure everyone still has access to their keys. So, through this ordeal, our team not only strengthened the app's security but also forged a deep understanding of the intricate dance between user accessibility and cryptographic fortification. It's a reminder that in the realm of app development, each upgrade must be orchestrated with finesse to ensure a harmonious user experience. Why am I sharing this story? It goes back to what I talked about in the first episode of the series. Mobile app security is important, but there are precautions to consider. For example, what strategy you go with, how you implement it, and when. You wouldn't want to have an issue like ours at a peak season because that will lead to revenue loss and even high user retention. We have mentioned the types of data, but when we talk about securing data, most of the time we refer to the sensitive data, right? Some of these may be authentication tokens, personally identifiable information like the your full name, email address, user preferences. We have user authentication information like pins and credentials. We also have, in part of the personally identifiable information, we have bank account numbers, even health information, credit card numbers. We also have device identifiers that may identify a user, highly sensitive data that would even harm or lead to reputational harm. Any data whose protection is a legal obligation, that's also important, and any technical data generated by the app, for example, encryption keys. So one may ask, if storing data creates a room for a hijacker to access it, why would we store data in the first place? So here's why. Storing data allows us to retain information beyond the current session, ensuring that valuable data isn't lost when a system is turned off or an app is closed. Also, in mobile app development, storing data is essential for preserving user preferences. This could include settings, themes, or any customization a user applies to enhance their experience. Data storage is also crucial for saving the state of an application. This ensures that users can resume from where they left off, providing a seamless and continuous experience. For apps that involve creating content like notes, images, or documents, data storage is necessary to keep this user generated content available even after the app is closed. Storing data locally also enables users to access information even when they are offline. This is particularly important for mobile apps, ensuring functionality in areas with limited or no internet connectivity. Also, frequently accessed data can be stored locally, reducing the need to fetch it from external resources. This improves app performance by minimizing network requests. Another reason will be storing user interactions and app usage data allows developers to analyze patterns and track user behavior and gain insights. This information is invaluable for making informed decisions about app improvements. Data storage enables implementation of security measures such as encryption. It also helps in adhering to compliance standards by securely managing sensitive user information. Storing frequently accessed or computationally expensive results locally, which we call caching, can significantly speed up certain operations, enhancing the overall responsiveness of an application. Data storage facilitates the creation of backup mechanisms. That's why we have backups, that ensuring that even if data is lost or corrupted, it can be recovered from a previous state. In applications where multiple users interact or collaborate, storing data is essential for maintaining a shared and synchronized environment. And keeping historical data allows for versioning and auditing, providing a trail of changes made over time, which is crucial for accountability and also troubleshooting. So you can see there's so many reasons. Now that we know why data storage is important, we need to find out ways we can ensure the app secures this data. We will explore the many data storage solutions that we have locally. This is because we are in more control as mobile developers with data held in app memory. Our main focus is on mobile apps installed in mobile devices, and therefore our focus is in the data stored in these devices. To make the most out of all this, we will also look at both the Android and iOS platform using native languages, Kotlin for modern Android, Swift for iOS, and also Dart for Flutter framework. So here's the challenge for today. What's the first thing you do when you lose users' data with no backup? Cringing, I know. Please feel free to dive into the comments below and maximize our discussion on this topic. Until then, subscribe, like, share, and I'll see you on the next one.